This is a lecture for writing and balancing a chemical reaction. So first, here's a list of different symbols you should be familiar with. Some, like, I won't exactly explicitly ask you to write down, but it can help you out. So if you have a plus, that means you're using to separate multiple reactants or products. You have an arrow pointing one way, it's a yield sign. It means these things are reacting to form. If you have a two-sided arrow, meaning pointing one way and the other, that means you have a reversible reaction. If you have an S in parentheses, that means that you're in a solid state. L is liquid, gas is lowercase g. AQ means that something is dissolved in water. In terms of honors and general chemistry, well, just in general, when you see these symbols, you don't need to balance those, in case you were wondering. The only thing you're balancing is the elements and the compounds, etc. If you have an arrow pointing with some kind of like water or heat, or actually not heat, I'm sorry. If you have like some kind of element on top of it, what that means is that something is acting as a catalyst. That's beyond the scope of this class. And if you see a delta on top of an arrow, that means heat is being applied. So delta means change, and also can mean heat as well. So this list you should know already by heart. These are the diatomic elements. So in nature, they exist as pairs. So whenever I say hydrogen or I say nitrogen, automatically I'm talking about these particular diatomic elements, like they're diatomic. So this should actually be H2, N2, O2, F2, Cl2, Br2, and I2. So whenever I say oxygen or oxygen gas, or just oxygen in general, I mean O2. If I say chlorine, like sodium and chlorine react, chlorine is automatically Cl2. Same goes for all of these. So how to do this? You identify the reactant and the product in the word equation. So I have hydrogen gas and oxygen gas. So this is H2 and O2, and it's forming water. So that's, you should know, H2O. Then you write out the chemical formula for each of the reactants and products, which I kind of already did. And then you balance the equation. So it was H2 plus O2 forms H2O. So this is my reactant side. This is my product side, just so we know. So to balance the equation, so we've done this equation already, but just to be thorough, I have two H's on the left, two on the right. I have two O's on the left and one on the right. So I'm going to put a 2 in the front here. That's going to distribute, meaning it's going to multiply in. So it's going to be now 4 H's and 2 O's. I look on my left side. There are 2 H's there, so I'm going to put a 2 here. And that means I have 4 O's now on my reactant side and my product side as well. My products have 2 O's, while my reactants now have 2 O's as well. So I'm good to go. We have 4 examples. Please follow along. So sodium metal reacts with chlorine gas, like I've said, to form solid sodium chloride. You don't really need to worry about the states of matter for this. So whenever you have a metal by itself, it's only one of that. Okay? Reacts with chlorine gas, so chlorine, the diatomic element, so Cl2, and it's forming sodium chloride. So you have to know your formulas, gentlemen. Sodium is Na, and Cl is chlorine. So just know your oxidation numbers, because remember, ionic compounds and polyatomics don't have prefixes, so you have to know which is which. So I did this up on top right here to show what oxidation numbers go with which. So Na is going to go with here, and then Cl, there's 1 and 1, so we're good to go. Now I got to balance this. I have 1 Na on both sides. I have 2 Cl's in my reactant and 1 in my product. So I'm going to put 2 in the front of the NaCl. That will distribute in. and you're going to end up with 2 NAs and 2 Cl. So I got to put a 2 in front of the sodium in the front, and then a 1 Cl2. Carbon tetrahydride reacts with oxygen gas to form CO2, carbon dioxide and water. So carbon tetra is 4, so it's 4 H's. Reacts with oxygen gas, or O2, forming CO2 and water. So now I got to balance this. I have 1 carbon on both sides. I have 2 H's on my product side and 4 on my reactant side. So I'm going to put a 2 in the front here. And now I have 4 O's on the product side and only 2 on the reactant side. So I'm going to put a 2 in the front here. And now I'm balanced for everything else. So it's best when you do this that you double check your coefficients. I have calcium carbonate decomposes to form calcium oxide and carbon dioxide. Maybe a little tricky if you don't know your names. So calcium is Ca, obviously, 2+. Carbonate is CO3, 2-. You have to know that. Your reactant is CaCO3. It's decomposing to form calcium oxide. So calcium is 2+, oxide or oxygen is 2-. So I'm going to crisscross these. I'm going to end up with CaO plus CO2. So I'm going to look. I have calcium, 1 calcium on each side. I have 1 carbon on each side. And I have 3 oxygens on my carbonate. And I have 2. It actually does not really look like that. And I have 3 oxygens on my right side as well. So this is 1, 1, 1. Silver nitrate reacts with potassium iodide to form silver iodide and potassium nitrate. Eesh. So you have to know silver is Ag, and it's 1+. NO3, 1- is nitrate. I have potassium iodide, so potassium is K+, iodide is minus. Ag is silver, iodide is I-. Potassium nitrate is K plus NO3. So what did I do like that? I did it so we can double check what are the numbers for each of my for my subscripts. But luckily for us, for this one, they're all ones all across. So silver nitrate AgNO3 reacts with potassium iodide Ki to form silver iodide AgI plus potassium nitrate KNO3. So I'm going to look, make sure how much I have of each particular element. And luckily for us, I'm going to be nice and tell you all we have just 1 of each single one. All right. So that is writing out and balancing equations just from words, not given symbols and all that. You have to know those names, guys. I told you that multiple times already. That's why we reviewed this when we came back from break. All right. If you have any questions, please let me know. Hit the like, subscribe. Thanks. Bye.